Hi students, let us take up a topic, cyclic process in the thermodynamics. Cyclic process. Cyclic process. What is this cyclic process? So, observe, if a system starts from an initial state and comes back to the same initial point, this is known as cyclic process. So let us say that A is a point and system is going from A to B. Again from B to A, if it is coming back, that is initial point and final point coincide with the same thing. This is known as cyclic process. Okay. Now I would like to explain this by means of some graphs. Observe carefully. So if I take up a PV graph, this is x-axis, or is it y-axis? So pressure on the y-axis, volume on the x-axis. So if I take up a point A, the system starts from the initial state, goes up to the point B, from the B goes up to the point C, from the C goes up to the point D, and again from the D, if it is coming back to the initial point A. This is known as cyclic process. Another example, if I take up another, this is x-axis, origin, y-axis. This is the pressure on the y-axis, PV graph, volume on the x-axis. If a system starts from the initial state A, goes up to the B, and comes up to the C point, again from the C, if it goes back to the initial state A, that means the initial state and the final state coincide. It's a cyclic process. Cyclic process. Clear? Okay. That means what is the fundamental criteria in cyclic process? In cyclic process, initial state of the system and final state of the system, coincide with each other. Very important point. Clear? Right. Observe, when we take up this cyclic process, if I apply this cyclic process to the state variables, in the earlier class we have seen about the state functions or the state variables. What are the state functions? State functions are state variables. Clear? So pressure, volume, temperature, entropy, Gibbs energy, Gibbs free energy, internal energy, all these are nothing but the state functions. Okay, they depend upon the initial state and the final state. We have discussed this. Suppose in cyclic process, if I want the change in pressure, so Pf minus Pi, final pressure minus initial pressure. Since in the cyclic process, initial point coincide with the final point, delta P is equal to 0. Delta P is 0. Similarly, change in volume, that is in the cyclic process, Vf minus Vi, initial point, initial state of the system coincide with the final state, hence change in volume is also 0. So here afterwards, in the cyclic process, basically I am talking about the cyclic process. So change in volume, change in state variables, because they depend upon the initial and the final state of the system. Since they coincide with each other. So change in temperature is 0, change in entropy is 0, change in Gibbs energy is 0, change in internal energy in the cyclic process is 0. Is clear? Right. Okay. Now I take up the cyclic process in case of the path functions. Earlier we discussed the path functions. So what are the path functions? Path functions. Path functions. These are path dependent. Previous class I told path dependent. Okay. Example, work and heat. Work and heat. Clear? In cyclic process, though the initial state and final state coincide with each other, though they are coinciding with each other, but change in work is not equal to 0 in the cyclic process. Okay? And change in heat is not equal to 0 in cyclic process. In cyclic process. Though the initial point and the final point, that is the initial state and final state coincide, but since they are path dependent, they are purely path dependent. Example, suppose if I take up the PV graph, pressure volume graph, suppose a system starts from the initial point A, comes up to the B point and reaches back to the A point, again initial state. Though there is initial and final point coincide with each other, so this is A to B is one path and B to A is another path. So work done in this case in cyclic process is path dependent. Path dependent. They are not dependent on the initial and final state. Okay students? So right.